In this lesson, we're going to examine the graphs of some exponential and log functions. So we've been working a lot on the algebra of like solving equations with these functions. Now we're going to tie these functions back to our ideas about domain and range and end behavior and x and y intercepts and all of that. And the way we're going to do that is just by annotating our graphs. So we're going to consider these first two first. We have f of x is 2 to the x and g of x is e to the x. And we're going to start with the y-intercepts of both of these. So those are where x is equal to 0. And notice for both of these graphs, our y-intercept is the point 0, 1. And also for both of these graphs, notice they kind of snuggle up to the x-axis. So they never touch the x-axis, so they have no x-intercepts. And this makes a lot of sense if we think about how this function would work, though. So if I plug in 0, anything to the 0 power is 1. So 2 to the 0 is 1. E to the 0 is 1 as well. So it makes sense that my y-intercepts would be 1 for both of these functions. And then no matter what I plug in, positive number, negative number, whatever I plug into these things, what it spits out will always be a number bigger than 0, a positive number bigger than 0. So that makes sense that we have no x-intercepts. And notice I can draw in an asymptote at y equals 0. And that's because as we plug in bigger negative numbers going to the left here, we get sort of, so for example, f of negative 100 here would be 2 to the negative 100, which is the same as 1 over 2 to the 100 power. So that's a pretty small, or pretty number that's pretty close to 0, a pretty big number on the bottom of my fraction, right? So this is a horizontal asymptote. And because of this idea, right, we can talk about the end behavior. Again, it's the same for both of these. So as x approaches infinity, f of x approaches infinity. So that's here, and these grow quite quickly. And then as x approaches negative infinity, f of x approaches 0 for both of these. And there's my horizontal asymptote. The next thing we're going to discuss is domain and range. So my domain is my x values. For both of these, it's negative infinity to infinity. Those always get parentheses. My range is my y values. And notice my range is kind of related to this horizontal asymptote because I want to say every value bigger than 0. So my range would be 0 to infinity. And 0 gets a parentheses because 0 is not included here. And then, obviously, over here, we have the same result. So notice, it's kind of interesting, right? All these properties are the same, regardless of the base of my exponential function. The last thing we're going to note, and this is just to help us when we consider our logarithmic example down here, is what I'm going to call a key point. And my key point is kind of related to the base here. So this is the point 1, 2. And this makes sense because f of 1, obviously 2 to the first power, is 2, right? And then notice over here we get this number a little bit bigger than 2. So this is the point 1, e, right? And that makes a lot of sense because g of 1 would be e to the 1 would be e, right? So again, this is just a key point in the function. When I plug in 1, I get the base. By the way, I just noticed I made an error here. In my end behavior, this function's name is g, so we don't want to call it f. All right, so that hopefully it should have been a nice review for you, considering what these properties mean. Now we're going to consider h of x here to start. So h of x, we have some transformations. So we have a vertical flip, a vertical reflection, and that of course is the negative, and then we have a translation to the right, and that's the -3 inside the function. And we're going to consider all of the same key points, right? So we have a y-intercept, and here we have to do a little bit of work, right? So my y-intercept would be 0, let's see, we have -2 to the -3. Or we could say negative 2 to the negative 3 would be negative 1 over 8, and that looks about right from the graph that we have, right? So notice we have reflected the graph and kind of shifted it. So my y-intercept is no longer 1 or negative 1, right? My y-intercept is a point that is a little bit closer to the x-axis. Now, let's consider our asymptotes and our end behavior. So we still have this asymptote at y equals 0. Our end behavior is as x approaches infinity, we're going down now, right? H of x approaches negative infinity. And then on the other side is now our horizontal asymptote side. So as x approaches negative infinity, h of x approaches 0. And then my domain and range, same idea, negative infinity to infinity is my domain. My range is no longer positive infinity though, because that says we're going up. We want to say we're going down. So the way we say that is we say from negative infinity to 0. Notice my smaller value comes first. And then my key point, let's think about that for a second. So what I'm kind of interested in here is the y value equal to the base, right? So my base is negative 2. I want to know what x spits that out. We'll consider why that is what it is when we found it. So that is here. So that is the point 4 comma negative 2, right? That means h of 4 is equal to negative 2, right? Right? And notice what happened, right? So my original point, my key point was 1 comma 2 right here, right? And we shifted it to the right 3 and reflected it down. So that makes a lot of sense. So that's why this point is kind of important, because it gives us sort of a starting place. So we couldn't use the y-intercept, obviously, but this gives us a starting place to consider the transformations that we did. Okay, so the last thing we're going to consider is my natural log function. So notice this is the inverse of this guy, right? And it makes sense because what we see is if I kind of reflected it over this line, I would get e to the x, right? And we're not going to draw that in our notes just so our notes are clear. So a lot of our properties we're going to see are related to this e to the x function up here. So the first thing we see, right, is that there is no y-intercept, but there is an x-intercept at 1 comma 0, right? And it makes sense that there is no y-intercept because I can't take log of 0. Log of 0 is undefined because exponentiating numbers does not give you 0 ever, right? But it makes a lot of sense that the x-intercept is at x equals 1 because log of 1 always equals 0. And it is the reflection of 0 comma 1. So e to the 0 is 1. That means e to the 0 gives me my y-intercept up here. And e to the 0 equals 1 gives me my x-intercept down here. As far as asymptotes now, well, it looks like we now have, and it makes a lot of sense if we're reflecting e to the x, we now have a vertical asymptote at x equals 0, right? And no horizontal asymptote, obviously. So we kind of snuggle up to this line. Log can never be negative, right? And it can never be 0, but can get really, really close. So that's, again, a reflection of this horizontal asymptote here. And my end behavior, then, is as x goes to infinity, k of x goes to infinity. Very slowly, however, but it does. As x goes to negative infinity, we'd say k of x goes to 0. Right? And that is describing this portion of the graph. And then my domain and range and my key points. Okay, so my domain is again going to be related to the end behavior and the asymptotes of the graph. In this case, my domain is 0 to infinity. And we never touch 0, so we use a parentheses, right? And then my range now is everything. Negative infinity to infinity. And notice that's the exact opposite of what we did up here. We should call that the range, right? And then finally, my key point, well, let's see. We were interested in the point 1 comma e. So my key point is really, where is my y equal to 1, right? And notice my key point is going to be, where is my y equal to 1? So here's y equals 1. It's going to be right here. And that would be the point 1 comma, notice we're a little bit bigger than 2, a little bit less than 3. That's 1 comma e, right? Because k of 1 is equal to e, because ln of 1 is equal to e. So in this lesson, we are really interested in the properties of these functions and what happens when we kind of shift them around, like in h of x here.